All right, last time we said that light can be considered a wave in the electric and magnetic field. So the electromagnetic spectrum is basically the spectra of all the different types of light. And remember that wavelength here is what determines the type/color of light. And remember we said small wavelength is high energy and large wavelength is low energy. And you can think of terms of frequency as well. So again, the most familiar section of the electromagnetic spectrum that you're familiar with is the visible light. So visible light is basically electromagnetic waves with wavelengths equal to from 750 nanometers down to 400 nanometers, right? And overall, there's nothing special about visible light. It's just that we have kind of built-in sensors to be able to see it. So we have eyes that can see visible light, but there are some other animals that can see non-visible light. And of course, we have instruments to see other types of light, like night vision, heat vision, that kind of stuff. So nothing special about visible light. We just have sensors built in to see it. And those are our eyes, right? So it just so happens that we see light in this spectrum. And we can detect other types of electromagnetic radiation with instruments. So let's take a look at the overall electromagnetic spectrum. So first off, I have this picture right here. And so you can see, you can think in terms of frequency or wavelength, either is fine. And so you can see visible light just makes up this tiny portion of the electromagnetic spectrum with wavelengths from 750 to 400 nanometers. And this violet color is higher energy because it has the lower wavelength, and then red is lower energy. And so I want you to be pretty familiar with this, kind of know what's a high energy wave, what's a low energy wave. So something like a gamma ray, right? That's high energy. Something like an X-ray, that's high energy. So when you go take an X-ray, you kind of have to protect your other bodily organs. Something like ultraviolet light is high energy, right? That's what gives you a sunburn. And then on the other side, things are lower energy like infrared. That's what we use for our heat vision. Microwaves are actually pretty low energy. That's what you use to heat your food. And then radio waves are also low energy because we've always got them buzzing around. So we wouldn't want kind of any high energy stuff there. I got another picture here for you. You can see right, so kind of the same picture as above. You can see visible light is just a tiny portion of it, but then it gives you uses for all these other wavelengths of light, like our night vision, our TV remote, wireless data, all that kind of stuff. And then you can take a look at this little kind of picture, right, towards the right side here with like radio waves and whatnot. We get very large wavelength. And so if you look at this, this wavelength is 1,000 meters. So that's pretty huge. That's like the size of a kind of, I don't know, maybe medium sized skyscraper, something like that. So waves can be really huge, or on this other side, 10 to the negative 12, that's about the size of an atom. So waves can also be really tiny. And again, large frequency means a smaller wavelength, which means a larger amount of energy and vice versa. So be comfortable between the relationships between wavelength, frequency, and energy of light. And so classically, light has generally been described as a wave, but we'll see that's not always true.